Hi, in this video we're going to be looking at trigonometry identities, proving left-hand side equal to right-hand side or the other way around. So let's look at our first question. We have 1 over cos theta minus cos theta over 1 plus sine theta, and we're going to prove it equal to tan theta. So we're going to start with our left-hand side, as it will be easier for us to simplify the left-hand side. So we see we have denominators. So what we're going to do here is we're going to find our LCD. And our LCD here is cos theta into 1 plus sine theta. So to make the denominators the same, we need to go to the first term and multiply the numerator 1 by 1 plus sine theta, as we can see in the bottom. And then we're going to go to the next numerator. There's a minus sign there, which is cos theta, and we're going to multiply that by cos theta. And if we do that, we will end up on the top with 1 plus sine theta minus cos squared theta. And all over our common denominator of cos theta into 1 plus sine theta. Now, I want to remind you of an important formula in trig, which says that sine squared theta plus cos squared theta is actually equal to 1. And we're going to use that because we see a 1 there. So we're going to replace that 1 with sine squared theta plus cos squared theta. That's our 1. And then we're going to bring the rest of the terms as it is on the numerator, which is plus sine theta minus cos squared theta. And you can see those are the two terms I brought down. So I replaced the 1 with sine squared plus cos squared all over a common denominator of cos theta into 1 plus sine theta. And you'll notice now that the minus cos squared and the plus cos squared cancels off. So on the top we have sine squared plus sine theta. And now we can pull out a common factor on the top, sine theta. And if we take out sine theta from sine squared theta, we're left with sine theta. And then we have sine theta over sine theta. Sorry, we don't want a bracket there. That'll give me a plus 1. All over our LCD, which is cos theta into 1 plus sine theta. Okay, and you'll notice sine theta over cos theta will actually give you, and I don't want to cancel it off, but should be saying sine theta over cos theta is actually tan theta. So I just want to erase that. And on this side, we've got sine theta plus 1, 1 plus sine theta, which is actually the same thing. And that actually gives us, or it's equal to tan theta, which is the right-hand side. So we started with the left-hand side, and we managed to get it to be equal to the right-hand side. Okay, let's go to our next question. And in this one, it says, prove the identity 1 over cos x plus 1 into cos x minus 1 is equal to minus 1 tan squared x over cos squared x. So we're going to start on the left-hand side. Remember, you can also start on the right-hand side. Doesn't matter, as long as you get to the other side. And I'm going to multiply the bracket out. First times first. Sorry about that. Cos times cos. And 1 times minus 1. The inside and outside terms would cancel off. So I can say the left-hand side is actually 1 over cos squared x minus 1. And I did tell you earlier that we can replace 1 with sine squared plus cos squared. So that gives us 1 over cos squared x minus sine squared x plus cos squared x. And negative will change your signs, and you're going to end up with 1 over cos squared x minus sine squared x minus cos squared x. And you'll notice that your minus cos squared and your plus cos squared x will cancel off. So now we got 1 over minus, and I'm going to write that properly. That's 1 over, let's put an x there, minus sine squared x. And I'm gonna park it right there at the moment. And I'm going to go to my right hand side and look at what's happening on the right hand side. So I want to remind you of something which is very important for us to use now, that tan x is equal to sine x over cos x. And if you flip this around, you can say that 1 over tan x is actually equal to cos x over sine x. And that's what I'm going to use here. I'm going to now say, okay, we got our minus 1 on top, as you can see. But I got tan squared. It's 1 over tan squared, which is cos over sine. So I can represent that by saying cos squared x over sine squared. Computer just jumped, over sine squared x. So I'm actually replacing 1 over tan to be cos squared over sine squared. And then you'll notice in the bottom, I still have another term called cos squared x. And what happens there, you'll notice that cos squared x and the cos squared cancels off. And that gives me minus 1 over sine squared x, which is actually equal to your left-hand side. Okay, going to another question. We want to prove this. So once again, I'm going to start with my left-hand side. And remember what I said about 1, that 1 can always be replaced with sine squared plus cos squared. And if I do that, so we're going to replace the 1 with sine squared x plus cos squared x. And we're going to bring down the remainder of the terms, which is minus sine squared x minus sine x cos x. And you'll notice that sine squared minus sine squared on the top will cancel off. And in the bottom we got difference of squares, so we can actually factorize that and say that it's cos x plus sine x into cos x minus sine x. Skip very quickly. So we factorize the denominator. And if we look at the top, you'll notice that we have I just want to highlight that for you. We have cos squared x, and we've got a minus sine x cos x. So what we can do on the top right now is we're going to pull out a common factor. Okay, so on the top we have cos x as a common factor, which I'm going to pull out. And cos squared x over cos x, that leaves me with cos x, minus, if I take out cos x from the second term, I'm left with a minus sine x. And then in the bottom I have cos x plus sine x into cos x minus sine x. And now you'll notice that cos x minus sine x will cancel off, and that looks exactly like the right hand side. So we have proved that as well. We're going to do our last question. And before we do this question, you'll see we notice we have a tan, 1 over 10. And I want to remind you once again that tan x is equal to sine x over cos x. And if we flip both sides, we get 1 over tan x is actually equal to cos x, sorry about that, is equal to cos x over sine x. And you'll notice that is what I'm going to apply here. So if I start with my left hand side, we have 1 over 10x, or 10 alpha I should say, which will now become cos alpha over sine alpha. And then we have in the bracket sine alpha. Now we have 10 alpha, which we're going to replace by sine alpha over cos alpha plus cos alpha. Okay, so we're now going to use distributive law and multiply the first terms out. And if you do that, you'll notice that the cos and the cos will cancel. So I'm going to show you that in a special color. You'll notice that your cos and your cos will cancel, and then you got in your denominator the sine alpha, so we should be left with sine alpha. Then we're going to multiply the first with the last using distributive law once again. And if we do that, we're going to get on the top plus cos squared alpha all over sine alpha. Okay, so what we're going to do next is put the sine alpha as a fraction, and now we have a common denominator called sine alpha. And we're going to multiply the first numerator by sine alpha to make the denominators the same. And sine alpha times sine alpha will give us sine squared alpha. And then the second denominator is sine alpha, so we don't have to change that. We're just going to bring down the numerator. And then we have a formula on the top that sine squared plus cos squared is actually equal to 1 over sine alpha. And that actually is equal to what we're looking for on the right hand side, which is 1 over sine alpha. Thank you.